It will sometimes be useful in solving problems involving percent change to express the final amount as a percent of the starting amount. That percentage that we get, the final amount is a percent of the starting amount, we'll call the final percent. And now if we know the starting amount and the final amount, this is really easy to compute. Clearly, just from the way that we're describing it, we'll know that the final amount over the starting amount will equal the final percent over 100. But the times when we'll really be interested in this are times when we're trying to find one of these quantities. How can we find the final percent if what we know is the percent change? This is going to work a little bit differently depending on whether we're talking about an increase or a decrease. Why? Well, if our quantity increases, we add to the starting amount. If we're seeing an increase, we take what we started with, add on how much we increased by, and that gives us how much we end up with. If we write all of these over the starting amount, well, that's still true, right? Since these are all fractions with the same denominator, we're just adding together the numerators, and that still works out. But then, well, this is going to be equal to 100 over 100, right? Same numerator and denominator. This is 1. This is also 1. From the way we defined the percent change is going to be the percent increase over 100, and that'll equal the final percent over 100. So that means that 100% plus the percent increase is going to give us the final percent. And notice that it makes sense to add these together. Why? Because they have the same base and no overlap. So let's see an example of this in action. Suppose a quantity increases by 37%. Then the final percent is 100% plus 37% is 137%. I'm going to have you try one of these as well. Suppose a quantity increases by 103%. Find the final percent. Pause the video and try it now. Well, again, the final percent is 100% plus the percent increase, so 203%. That means that the final amount is 203% of what we started with. Again, percentage more than 100 because we ended up with more than what we started with. What we do for decrease is similar but different. If we have a decrease, we subtract from the starting amount. That is, the starting amount minus the amount decrease gives us the final amount. So if we follow the same logic as we used for percent increase, we can pretty easily see that to find the final percent, we should take 100% minus the percent decrease. So percent increase, add to 100, percent decrease, subtract from 100. For example, suppose a quantity decreases by 17%, and the final percent is 100% minus 17%, which if we write it out, we have to borrow, but we get 83%. One thing to notice here, it's not going to make sense to see a decrease of more than 100%. Why? Because then the final percent would have to somehow be less than 0. An increase of more than 100% makes sense, but a decrease of more than 100% just doesn't. Let me give you an example here to try. Suppose a quantity decreases by 80%. Find the final percent. Pause the video and try this now. Alright, well the final percent is 100% minus 80%, which works out to 20%. In the next video, we'll talk about how we actually use this notion of final percents.